Hello Year 9 and welcome to the first of our live streaming lessons. I'm just going to do a short one today to test whether it works. I have done one with, I have done another test, but this is going to be our first test with Year 9. So this is currently for all Year 9 students, and it's going to be the lesson which is the volume of a prism. So you'll notice here that I've got our starter, which talks about the different types of prism. Now I just want to talk about what a prism is first of all. Now a prism is a 3D shape where anywhere you cut down that shape, you get the same shape. So an example of this might be a cylinder. I'll show you a cylinder. So here we have a cylinder like so. And anywhere you cut down that cylinder, you'll end up with a circle. Okay. Another shape of this is a triangular prism. And with this one, anywhere you cut down that shape, you'll end up with a triangle. Okay. So anywhere you cut along all of these, you'll end up with the same shape. Now, I just want to talk to you about things that aren't prisms, okay, because this is really important as well. So, if you think about a pyramid like this. So, here's a pyramid. Now, you might think that because there's triangles on this is like a triangular prism, but actually, what happens when I cut along here is that I actually get different size rectangles going up, and because of these different sizes, it means that it's not a prism. Okay, so what we're looking at here next is I want to show you that I want to show you what the different types of prism are. So here we've got a cylinder. Okay, that's the first one here. That's the first name of this shape. It's a cylinder. So this is a cylinder. Now we know every shape down here is a circle. This one here is a cuboid, and every one down here, I'll show you the cuboid again, is a rectangle there. It's not the best cuboid to have. We have a trapezoid, which you can see on the third one along, which every single shape there is a trapezium, and the last one there is a triangular prism. Every single shape of there is a triangle. So if you've got your books or if you're making notes, it's important at this stage to realise that actually you must be able to know with this the area of each shape, because we're going to use that lots in this. And that would have been the start of our starter here today. So what is the area of each of these shapes? So the first thing you want to think about is I've done a circle on this one. A circle. Now with a circle, we know from the centre to the edge is called the radius. We know that all the way across is called the diameter. And the area of a circle is equal to pi r squared. Okay, which means pi times radius squared. Now do be careful with that, because sometimes you're given the diameter and you'll be expected to halve this to get the radius. Okay, and sometimes you're given weird shapes, like you might get a semicircle, but we'll cross that bridge if we come to it. The other shape that you need to know the area of is a rectangle. Okay, with a rectangle we've got our length here and our width. And the area of a rectangle is equal to length times by width. We've also got here a trapezium. Now this one's a little bit strange. This is the one that people tend to forget. Okay? But what you need to know is you need to know the top, which is called A. You need to know the bottom, which is called B. And you need to know here the perpendicular height. Now I say perpendicular height on purpose, because it has to be the vertical height. Okay, you can't use this edge over here because that's diagonal. Okay, it's not perpendicular. It has to be the perpendicular height, and this is called h. Okay, so the area of a trapezium, for this one, is equal to A plus B divided by 2 times by h, which is the perpendicular height. Now, the way I like to think about that is you kind of averaging out these two heights. It is very similar to length times width, but you're averaging out the A and B, and the average means that you add them together and divide the amount they are. So here we're adding A and B together, and we're dividing by the amount they are, which is 2, to average out the top and bottom, and then we're times them by the height. So A plus B divided by 2 times by h. And the last shape that we need to think about is a triangle. Now, the amount of times I see people get this one wrong, it doesn't really matter what you call these, because they don't tend to say the bottom is the base or the top is the height, but in the formula that's the way that people tend to use it. Sometimes they give the height in here, sometimes they give the height here like this. Okay, again, it has to be perpendicular, so it has to be at right angles to both of these. It has to be the vertical height. And the area for this one, you should know this one anyway, I think, is going to be base times by height. Remember, this height could be inside or it could be outside. But what everybody always forgets to do is divide by 2. So base times height divided by 2. So now we know some of the areas which we'll need to know for the volume of a prism. Let's get into the lesson. Let's think about the lesson, which is the volume of a prism. So, I spoke to you earlier about the fact that a prism is a shape where anywhere you cut along this shape, anywhere you cut along the shape, you get the same shape. And this is any prism, really. Okay? So it doesn't matter what this looks like. You could draw it as an L shape, let's say. Have a look at that L shape. And if you know the area of the front of that L shape, then you can work out the volume, okay? Because the formula, in fact, write this down if you've got your books, okay? Because this is the important part. The volume of a prism is equal to, I'll get it on the next slide because I think sure it's on there. Nope. The volume of a prism is the cross-sectional area times by your depth. Now with this, you need to be thinking about the fact, you'll probably be thinking about the question, what is that cross-sectional area? What does that mean? Well, the cross-sectional area is the face at the front. This is the face at the front, where anywhere you cut along this, you'll get the same shape. So if I go back to the cylinder, the cross-section of this one is a circle. And we know that the area of a circle we've just worked out is pi r squared. We know the cross-section of this one is a triangle, and the area of this is base times height divided by 2. So the cross-section is that front face, where if you cut it, you'll get the same. Okay? So this is really important. It's the cross-sectional area. Notice that I say the cross-sectional area now, which is this area, times by your depth. Okay, your cross-sectional area times by your depth. And this is the area. Notice that I've shaded all of this because it is the area. It's not any one particular length. It's the area of that. Okay, this is really important. This is what you'll need to get down in your notes. Okay, so I think it's about time to have a look at a question. So I'm going to move on to the first one here, which is this shape here. Now, this is the volume of a triangular prism, okay? And that means that the cross-section is a triangle. So that's what I'm going to draw first. You don't need to draw this out. It'd be nice if you could. Just a little hint, if you do want to draw any prism or if you do want to draw anything like this, the easiest way to do it, if you struggle with it a little bit, is to draw the cross section. Okay, so draw that bit there. Go up and right. Draw the cross section again, trying to make sure that, well, it should be equal, and then connect all of the same. So here you'll notice then you get that triangular prism. So if you draw the triangle, you go up and right, draw the triangle again, and then you've got your prism. So if you want to draw that. Now you'll notice with this one, we have the height of this, which is 4.1 centimetres. We have the base of this, which is equal to 8.6 centimetres. And then we have the depth of this, which is 6.2 centimetres. So the first thing I need to do with this is work out the area of that cross section. Okay, I'm just going to go and grab my calculator. So we know that the cross section is this front bit here. So we've got to work out the area of that front bit first, and then we can times it by the depth. Now we've just talked about the fact that we know all the areas of these 2D shapes. So this is a triangle, and we know that the area of the triangle, it's worth writing this down, you're going to get the marks for this. The area of the triangle is equal to base times by height, not forgetting to divide by 2. So with this one here, we have 8.6 times by, so this is the base, times by 4.1 divided by 2. Okay, I'm going to put that straight into my calculator. So 8.6 times by 4.1 divided by 2. So that gives me 17.63. Now I'm going to write the units on that. Now because this is area, the units of this are equal to centimetres squared. Okay, which means that the area of this cross section here, this part at the front, is equal to 17.63. So what we need to do now is we're looking for the volume of this. Now it's only an extra little step here from the area, and this simple step is to times by this. So I am going to make it really clear to the examiner, saying that the volume is equal to the cross section times by the depth. And I know that the cross section is equal to this, so 17.63 times by the depth, which in this case is equal to 6.2. So we end up with 17.63 times by 6.2, which in this case is equal to 109.306. I'm going to round that to one decimal place. I'm going to do 109.3. Now the units on this are centimetres cubed. Okay, because it's volume. We're talking about the amount of cubes that you can fit into this. And that's that question done. Now I've started with the triangle on purpose because a lot of people here will start off with things such as cuboids, and people then get stuck with saying things like, well, I just times them all together. And that does work for a cuboid if you know what each of the lengths are, but actually what you're doing with a cuboid is you're finding the area of the front and then you're timesing by the depth. So you're doing length times by width and then times by the depth. So let's just make sure we've got that right. So there we go. So I'm going to move on now to a circle. Sorry, I say a circle. This is a cylinder. Okay. It's a very, very similar way. Okay. It's not too different. Okay. The hardest part with this is probably remembering what the formula for a circle is. Okay. I'm going to draw this circle. Sorry, cylinder. Remember my little trick. You draw a circle. You go up and right. you draw another circle. I'm going to put here, notice that this is from the centre to the edge, which is 3. So they're actually giving me my radius, not the diameter. And then the depth of this one is 5 centimetres. So, thinking first about what is my cross-section. So in this one here, my cross-section is a circle. So you've got to think about what the area of a circle is. Okay, so we had some connection issues there. I think I've sorted them. I'll try and merge those videos later. So, going back to the volume of a cylinder, we talked about the fact that we've got a cross-section, which is a circle, and we are going to be looking at that. Okay, so what is the area of the circle? Well, we know the area of a circle is equal to pi times by the radius squared. Okay, I'm told what my radius is here. My radius is equal to 3. Okay, I'm actually going to keep this in terms of pi. Okay, so my area in this is going to be equal to pi times by 3 squared. I can do that on my calculator. It will give me 2 values. So shift, if we want to find pi, just to make it really clear on here. To find pi, pi is on the bottom in the middle here. You'll notice there it is. Okay, so to get pi, you've got to press this shift button. So shift pi times by 3 squared. Now that's going to give it me in terms of pi, which is 9 pi. Okay, 9 pi, again this is area, so centimetres squared. If I wanted to, I could write this as a decimal, so not in terms of pi, and I do that by pressing this S to D button. So I press S to D, it's going to be 28 point, in this case, 274. And again, I could carry that on, centimetres squared. Now the reason that I've decided to use this one here, so use 9 pi instead of that bottom one, is because this is more accurate. Okay, here I've had to round this to 4 decimal places. But actually, this takes into consideration all of those decimal places. Okay, so this is the area of that front there. The area of this now, I know, is equal to 9 pi centimetres squared. That is the area of the front. So then what I need to do to find the volume of this, I need to times this by the depth. And the depth here is this 5 centimetres. So the volume is equal to your cross-sectional area times by your depth. And in this case, your cross-section is the 9 pi. Your depth is that 5 centimetres, so 9 pi times by 5 centimetres. So this one here, 9 pi times by 5. So 9 shift pi times by 5. I mean, we should be able to do that in our heads anyway, really, because 9 times 5 is 45. That's equal to 45 pi. Now remember, this is volume, so the units are centimetres cubed on that. Again, you could write that as an actual number. So it'd be 141.37, I'll do. Again, centimetres cubed. Now you can write either of those ways, because this one here, this question doesn't tell me whether it wants it in terms of pi or rounded to 1 or 2 decimal places. However, we know that this is more accurate. Okay, this 45 pi is more accurate. Okay, so I'm going to move on. I'm going to do one more, I think, and then I'm going to give you a chance to have a go at some yourself, because I think that you should be able to have a go at these now. Now, this is the one that everybody always does first. Everybody always does volume of a cuboid first, because they see it as the easy one, okay? And it is the easy one, yeah? But it's not about just multiplying all of these sides together. Multiplying all the sides together does work, okay? However, what we're looking at here is the fact it's the cross-sectional area times by the depth. So here I've got a height of 5.3. I've got a width here of 7.2. Sorry, my 7.2. I wrote 7.2. And I've got a depth, in this case, of 10.6 centimetres. Should put centimetres on all of those. So the first thing I'm going to do is work out the area of the front of this. So the area of the front is equal to length times by width, base times by height. Doesn't matter what those labels are called really. Okay, in this case it's going to be length, which is 7.2, times by the height, which is 5.3. I'll do that on my calculator. So 7.2 times by 5.3, in this case, is equal to 38.16 centimetres squared. So now what I need to do is I need to work out the volume of this. And the volume is going to be equal to, so the volume is going to be equal to the cross-sectional area in this, which is equal to that 38.16, times by the depth in this, which is equal to 10.6. So it's going to be 38.16 times by 10.6. So 38.16 times by 10.6, which in this case is equal to 404.5. I'm going to round it to one decimal place. And that's going to be centimetres cubed because it's volume. So it would have worked if I just times all of these. That's fine. But you've got to understand the theory behind why that works. Because it's the cross-sectional area times by that depth. Okay? So what I'm going to ask you to do now is I'm going to move over to this. And I want you to have a go. Let's cut back for a second. I want you to have a go at these sets of questions here. Now you can pause these, okay, when I put it on in a second. I will put the answers up in a second. There's no point me waiting. So notice on these top ones here, the green ones, okay, they've already given you the area. You don't need to work it out. You're not doing base times height. I will do an example of that because I haven't done one of those. So that first one here, these first top ones are really easy, okay? Because it tells you that the area is 25 centimetres squared. So you know that all of this area is already equal to the 25 centimetres squared, and it tells you the depth is 10. So with this one here, all we're doing is the area, which is the bit which is already shaded, 25 centimetres squared, times by the depth of this, which is 10. So the volume of this is going to be 25 times by 10, which is 250 centimetres cubed. So that's that first one done for you. I'll give you a little hint. Remember that on those purple ones, you've got to think about the area of a trapezium, okay? Now the cross-section of a trapezium is equal to, the area of a trapezium. I'll draw a little trapezium here so you know. A, B, and then the height is equal to A plus B divided by 2 times by that perpendicular height. A plus B divided by 2 times by that perpendicular height. Okay, I'm going to put this up. You can then pause that, have a go at these questions. These are only simple ones. And actually, more likely, you're going to have to work backwards of this. And I will do a video on looking at those potentially later today or tomorrow. Okay, but for now, just have a go at these questions. And then I want you to pause it as soon as I put it on. And then I'm going to put the answers up and then you can mark it. So pause now. And I'm going to put the answers on. So there's all the answers to those, so you can mark those. So you should have paused that, had a go at the questions, and then there's all the answers to have a go at. Okay, thank you, Year 9. This is your lesson for today. I will be doing these quite regularly. Hopefully they'll look a little bit more slicker. And I will send you an email out about this today. Bye.